Okay, so we know how to take a derivative, right? Well, we think we do. But then there are exceptions. There are times where we're going to have to pull out something from a bag of tricks that's going to be a little bit different. Let's suppose that we are multiplying two functions together. Let's suppose that we have some h function that is really f times g. And we want to find the derivative of that. So like up to this point, we can take the derivative of pretty much any polynomial that we wanted. We could say, oh, I know the derivative of 4x squared. I know the derivative of 6x to the third plus 2x minus 1. Like we can take the derivative of all that. We can take the derivative of sine and cosine. We could take the derivative of 4 sine. But what if I wanted to take the derivative of, and let's look at the first example, 3x squared times sine? Well, now we're mixing some of this with some of this. So what's the rule for that? Or what if I wanted to divide? Again, we're mixing those things. So let's figure out a rule. Well, let's not figure it out. That actually is a little bit beyond the scope of what we're going to do. I'm going to give you the product rule, and I'm also going to give you the quotient rule. So if we have some function that is defined as dividing two other functions, this is what we do. So if I wanted to find the derivative of two things that are multiplied together, here is the rule. F prime times g plus f times g prime. There's the rule. If I wanted to divide, here's the rule. F prime times g minus f times g prime. Starting to look familiar, isn't it? It looks like this one until I draw this. All divided by g all squared. Okay, so our product rule. If two functions are multiplied together and I'm asked to find the derivative, I'll do f prime g plus fg prime, f prime g plus fg prime. If I have two things that are divided, two functions divided, and I'm asked to find the derivative, f prime g minus fg prime, all divided by g squared. Okay, let's walk through the first two examples. They are basically the same problem with, well, they have the same component parts, but this one is multiplied, that one is divided. And I'm going to walk you through a process that is probably necessary for the first few problems, but after a while you'll start doing a lot of things in your head. So I personally like to look at this and define what's what. I'll look at this and say, well, you know, I have two things that are multiplied together. And we're going to say that this one is f and this one is g. Whoops, wrote it f. Here's f, here's g. That's what I'm doing. So f is 3x squared and g is sine x. And I need to find the derivative because they asked me to find the value of the derivative at a specific x value, actually. So I need to find the derivative and then plug in pi. But in order to do so, I need to know what f is and g is. Found that. I also need to know f prime and g prime. So let's come over here and say, well, I know what f prime is. That would be 6x. I know what g prime is. That's cosine, because the derivative of sine is cosine. And now I'm going to use the product rule. This one is a product problem. So switching colors again. This is a product rule. For slightly obvious reasons, we are multiplying f times g. Here we're going to be dividing f by g. And I hope you noticed the little tagline. F and g are arbitrary. Maybe they gave you a function that was defined as f, and then we'd have to say that this was like h and k or whatever. But the structure stands. Whether you use f and g or not, the structure is the same. So the product rule says, I'm going to leave the x's out, f prime g plus f g prime, and I'm going to just put things in the right place. So as I do that, let's do it. Well, f prime g plus f g prime, f prime g plus f g prime. This is the derivative of the original function they gave us, which was defined as h. So we have found the derivative. Now we also need to find out the value of the derivative at pi. We need to know the slope at pi. So h prime of pi, this is going to get a little tricky, but we'll be okay. 6 pi sine pi plus 3 pi squared cosine pi. Okay, let's figure this out. 6 pi to sine pi, well, sine pi is 0, so this whole term is gone. And then we have 3 pi squared cosine pi. Cosine pi is -1. This is going to give me 3 pi squared times -1. That would be -3 pi squared. Okay, same idea, different problem. There goes. I'm going to write the f and the g again, even though they're the same for this problem. But it's a good idea, just for the first few problems, to get in the flow of identifying what's what, writing down the derivatives, figuring those things out, so we can go from there. And we'll have kind of a launching point. So f is 3x squared, and f prime is 6x. G is sine x, and g prime is cosine x, and we will switch colors. We are now dealing with the quotient rule because we are dividing two different expressions and calling it a specific function. So the quotient rule says f prime g minus f g prime, all divided by g squared, and we are going to plug these things into this formula, and it gets a little sloppier with the quotient rule, but we'll be okay. So the derivative is f prime g minus f g prime, all divided by g squared. There's a rhythm to it. F prime g minus f g prime, all divided by g squared. That's what I usually do. So f prime g minus f g prime, all divided by g squared. You have to hit a desk when you do it. So here's g squared, sine x squared. Let's put the squared there. Don't have to, but you can. If you put it at the end of this x, it's going to be wrong unless you put the whole thing in parentheses and then put the squared. Okay, I want to evaluate the value of the derivative at pi over 2, at x value of pi over 2. So h prime, we're running into the space for the next problem. It's okay, I'm actually going to do that one on the board. And we will have 6 times pi over 2. You'll have enough room for it down here anyway. This one won't take up too much space. Sine of pi over 2 minus 3 times pi over 2 squared cosine pi over 2. Let's put that in parentheses because it looks like fun. All divided by sine of pi over 2. I could put the squared here. I think for the sake of actually simplifying it, I'll put it there. Okay, let's figure some stuff out, and I think the obvious thing to do is start finding things that equal 0, and here's one of them. Cosine of pi over 2 is 0, so this entire term actually is gone. That leaves us with this, and we have, oh, I have space. Let's go for it. If you're running down here on your paper, it's fine. You won't need too much space for these. Probably should have given you more room. Sorry. So I have something kind of cool here. I'm just going to go crazy on you. You don't have to do it this way. Well, first of all, 6 times pi over 2, that's just 3 pi because the 2 and the 6 would reduce. And I have sine of pi over 2. And I know you're like, well, sine of pi over 2, I can figure out that. I can too. It's not that bad. But I just want to show you something cool that can happen in this process. This is sine of pi over 2, and it is squared, and the beautiful thing that's about to happen here is that we can cancel sine of pi over 2 with one of these two sine pi over 2's, and it's somewhat irrelevant because sine of pi over 2 is 1, but I just wanted to show you that process because sometimes it comes in handy and it's not as intuitive. Sine of pi over 2, and sine of pi over 2 is 1, so it truly is just 3 pi, and I didn't have to do all this reducing that I did, but it was fun. See, wasn't that fun? Yes, you know it's fun.